In this video, we will try to solve a problem that was asked in GATE economics paper of 2021. This question was asked by a brother Jalidmir on Telegram channel of Economaths. The question is like this: two farmers, Rohit and Harish, graze their animals on a common land. Okay, they can choose to use this common resource as lightly or heavily, and the resulting strategic interaction may be described as a simultaneous move game. Okay, so we have Rohit and Harish. They graze their animals. They can choose to graze the common resource lightly or heavily, and their expected payoff is given in this matrix. The minimum value, what we have to find, we have to find the minimum value of discount rate, where a discount rate is less than 1 under infinite repetition of the game. Okay, where the threat strategy is graze lightly if opponent also graze lightly, whereas if opponent renege, then always graze heavily in all future periods. Is a subgame perfect Nash equilibrium and both farmers graze their animals lightly is okay. So we have to find the minimum value of discount value. Now, what is meant by this discount rate? A discount rate is simply, let me give you an example. If a person is being offered, let us say $100 today, okay, $100 today, okay, he is also being told, okay, you can take this $100 tomorrow, okay, let us say this is tomorrow. I am just talking about the discount rate which we denote by delta. Now, here people value $100 tomorrow, that means this, less than $100 today, that means the value of $100 today is greater than the value of the $100 tomorrow, and we use the discount rate, let us say delta. Let us say we say discount rate is 0.8. okay. Now, what will then it mean? It simply means that $100 tomorrow, okay, $100 tomorrow is equivalent to rupees 100 into zero point 0.8 is 80. That means $80 today, okay. That means having $80 today is equivalent of having $100 tomorrow, okay, and this is given by this discounting factor, okay. And similarly, if we have n number of periods, this discounting factor will come along with that, okay. So let me explain it again. That means people value $100, okay, people value $100 tomorrow less than the $100 today, okay. The obvious reason can be we have the interest rate today, we will get more interest rate, okay. So value of $100 today will be greater than the value of $100 tomorrow, and we use this delta for discount rate, okay. So this is the concept of discount rate. Now what the question tells us, we have to find the minimum value of discount rate, okay. And we have here the threat strategy. And what is threat strategy? It is simply threat strategy in the sense that bad behavior by either players, in this case, triggers the punishment, okay, in the remainder of the game. And let me explain it, what is meant by this. So let's come to the question. So we have this very payoff matrix. Let us say what is the Nash equilibrium in this payoff matrix first. Then we will come to the question also. Okay. So let us say Rohit chooses to graze lightly. Okay, lightly. Okay. Harish has two options, either to graze lightly or heavily. Lightly gives him a 40 as payoff. Heavily gives him 55 as payoff. So he will choose this option. Okay. Let us say Rohit chooses heavily. Again, Harish has two options, either to graze lightly or heavily. Here we can see that heavily gives him more payoff than grazing lightly, okay. Similarly, let us take the case of Harish. If Harish chooses the strategy lightly, okay, Rohit have two options, either to use lightly or heavily. Here we can see heavily gives him more payoff than lightly, so he will choose this, okay. Similarly, if Harish chooses heavily, again Rohit has two options, either to graze lightly or what we call the heavily. Heavily gives him 30 payoff, lightly gives him 20 payoff, so he will choose this very option, okay. So we can see this is our Nash equilibrium in this case. Okay, now what we need to see here, we have to find out the minimum value of discount rate where both farmers graze their animals lightly. Okay, now let us see the payoff for Rohit and Harish when they first cooperate with each other. Okay, so when uh, they graze their animals slightly. Okay, so what will be the payoff? Payoff will be if they play fair. Okay, if they play fair, that means both are grazing their animals lightly in the field. So in the first move, Rohit will get 40. Okay, again. Harish will also get 40. After that, Rohit will get again 40 because both are cooperating with each other when they are playing fair game here. Okay, and subsequently they will get 40 in the next periods and so on. Okay, let us say if they cheat. Okay, let us say if they cheat, that means in this case, let us take the case of Rohit. If he is cheating, that means he is grazing his animals heavily. Let us denote it by H. So first time he will get a payoff of 5500. Sorry, 55 here. Okay, but seeing that Rohit has cheated on Harish, Harish will in turn punish him. Okay, uh, by choosing the strategy heavily in the next period, and Rohit will get in the next period as payoff of 30. Okay, what we call by the threat strategy. Okay, that means if any of the player cheats, then other player will cheat in the next stage of the game. Okay, similarly they will both punish each other, and Rohit will get subsequently 30 and 30 and so on is payoff. Okay, so this is the payoff for playing fair, and this is the payoff for playing cheat. But we have to use the discount factor here. Okay, as I told you, having $100 today is much more valuable than having $100 tomorrow, and we use some discount factor here. Okay, let us denote it by delta here. That means uh, both players in this game, both players will play fair as long as, let me write it here, both players will uh, play fair. Fair, that means both players will cooperate with each other. Let me write it like this. Use strategy L as as long as the utility by fair strategy, that means grazing lightly. Let me write it like this. If the utility by fair is greater than the utility from cheat. Okay, by cheat we mean here heavily. Okay, let me repeat it here. Both players will play fair in this game. That means both players will choose this strategy lightly. Okay, if the payoff from lightly or utility from grazing lightly is greater than from cheating each other, that means choosing the strategy H, that means heavily. Okay, so what is the utility then? What is the utility of fair? Okay, let us calculate, or payoff for fair will be in the first move Rohit will get 40, plus in the next move he will get also 40, but with some discounting factor. Let's denote it by delta. In the next period he will get 40 delta square. Okay, and we assume here this discounting factor is constant, and obviously it is less than 1 here. Okay, so this will come out to be the expected payoff for Rohit in the subsequent periods, and this game is being played under infinite repetition, so we will have 40 delta cube plus and so on to infinity. Okay, this is the utility of playing fair. What is the utility of playing cheat? Okay, so utility or payoff from playing the strategy cheat will be. So first, if Rohit cheats, okay, so he will get 55 as payoff in the first stage, okay. Seeing that Rohit has cheated, Harish will punish him by what we call by, he will use the threat strategy. Rohit is since Rohit is cheating, he is getting 55. Harish will get 20. But in the next move, Harish will punish the Rohit and he will play heavily, and Rohit will get only 30 in the next stage. Okay, so we have 30 delta, that is the discounting factor. Similarly, they will continue to punish each other, and Rohit will get 30 delta, which I have explained here, square plus 30 delta cube, okay, and so on up to infinity. This is the utility from playing fair. This is the utility from playing cheat, and this is both this is true for both the players here, okay. Now I have told you both players will play fair as long as the utility of playing fair, that means using this lightly strategy, is greater than the utility from cheating, that means playing this heavily strategy, okay. Now what is the sum of this series? We have the geometric series, infinite geometric progression series, okay. What is the sum of this series? Simple thing, if you know the what you call the geometric series sum formula, it is being given by that sum of this series will be equal to, the sum of this series will be equal to, let me write it here, so this will come out to be 40 upon 1 minus delta, okay. I will explain it further, but let us say this is this thing, okay. Actually it is being given by sum of n terms in an infinite series is equal to first term, that means, let me write it here, so let me explain it here. So first term 1 minus the common ratio, okay. What is the common ratio here? So if we divide subsequent terms with each other, what will be the common ratio here? So if we divide 40 lambda 40 delta by 40, so 40 delta by 40, so we will get here delta. Similarly here 40 delta square upon 40, 40 delta square upon 40 delta, here we also get delta. Since the common ratio is same, we say these terms are in geometric progression, okay. And sum is given by this very formula, okay. First term is here 40. Now what is the sum of this series? Okay, let's take this, let's not take the first term, so we have sum will be equal to 50, okay, plus using the geometric sum formula here, what is the first term? First term is 30 lambda, so let me write it here, 30 lambda, sorry, delta upon 1 minus what is common ratio, again here we have common ratio is delta, okay. I hope I am making myself clear. This is the sum of the infinite geometric progression series, and this is given by this very thing, okay. And obviously this delta is less than 1, which is being given us here. Now that means uh, let us use this very equation here. Utility for playing fair came out to be this 40 40 upon 1 minus delta. If it is greater than the utility from playing cheat, that means this very thing, the sum of this payoff, which came out to be 30 delta upon 1 minus delta, okay. The point to make here is that both players will play this grazier animals lightly as long as the utility from playing fair, that means by cooperating with each other, is greater than the utility from cheating with each other, okay. So let's you solve this very inequality here. So we have 1 minus delta, 1 minus delta here. If we multiply both sides by 1 minus delta, so let's multiply 1 minus delta here. In this we have to multiply 1 minus delta to each of the terms. So here if we multiply 1 minus delta, let me write it should Okay, so let us 1 minus delta multiplying to this term, so we have to multiply this term also 1 minus delta. You can see this term and this term will get cancelled, this term, the term gets cancelled, so we are left with implies we have 40. 40 is greater than, so we have actually 55 here. Okay, so first term is 55. That means we have 55 into 1 is 55, 55 minus 55 delta, okay, plus 30 delta. Okay, now let's solve this out. So if we transpose this 55 here, okay, when we add or subtract, inequality sign does not change. Okay, so we have 40 minus 55 is greater than minus 55 lambda plus 30 lambda comes out to be minus 25 delta. Okay, now 45 minus 55 comes out to be kota area panda, that is minus 15 is greater than minus 25 delta. Okay, if we multiply both sides by 1, sorry, minus 1. Okay, if we multiply both sides by minus 1, let me write it like this. If I multiply here minus 1 minus 1, the inequality sign will get changed. Okay, so minus into minus is plus, so this becomes 15. Inequality sign will change, so we have 25 delta. Okay, how, why does this multiply sign changes? Simple thing, let us say 5 is greater than 2. Okay, if we multiply both sides by minus 1, so we will have here minus 5, here we will have minus 2. Okay, obviously minus 2 is now greater than minus 5. That's why when we multiply both sides by minus, the inequality sign changes. Simple panda I have explained it here. Okay, so we can write it like this. Let me write it here. So we can write 25. We have 25. 25 delta is greater than 15, which implies delta is greater than 15 upon 25. That means the discounting factor is it comes out to be 0.6. And what does this discounting factor tell us? So here we have 0.6. This discounting factor tells us both players need to care about future or for the next stage of the game at least 0.6 times as much as today. This is the essence of this this discounting factor. Okay, so I hope I make myself clear in this video. So let me repeat it for you people. What we were being given, we were being given this payoff matrix for Rohit and Harish. We were being told to find the minimum value of discount rate. Okay, whether that, where the threat strategy is being played. That means by threat strategy we mean if both players cooperate, they will be playing this very lightly and lightly. If any one of the player cheats, then other player also cheats, and we have to see what is uh, and both farmers graze their animals lightly. Okay, what is the utility that both farmers graze their animals lightly? If the utility from grazing their animals lightly is greater than the utility they get from cheating, that means grazing heavily. If it is greater than if it is greater, then both players will play fair. And we have what you call, we have first to calculate the expected, sorry, we can't say the expected, the payoff from playing fair. We have seen payoff from playing fair is that very thing, discounted by a factor delta here. Okay, as I have told you, having today $100 is better than having the same $100 tomorrow. That is why we use this discounting factor. And from cheating, this is the discounting factor. If this thing is greater than this thing, that means payoff from fair play is greater than payoff from cheating. And from that we get the value of uh, delta, let me write it here, it is not equality sign, this is greater than. If this delta comes out to be greater than 0.6, then both players need to care about future at least 0.6 times as much as today. Okay, I hope I make myself clear in this video. Thank you.